This 4-story condo complex is being platform framed, meaning each story is fully completed before the next one is started. First thing that happens is the layout. The top and bottom plates are marked for stud locations. It's a direct takeoff from the blueprints. This guy's got a really important job, transferring the measurements from the prints to the plates. If his measurements are not spot on, there's going to be big problems later on down the line. Since we're on the 4th floor, the best way to get lumber up is with a crane. The crew can now start assembling the walls. It's a matter of measuring, marking, laying everything out, and then nailing it together. Every wall will be assembled on the ground and then tilted up in place. The way that this guy cuts blocking, you can tell he does it a lot. New codes require quite a bit of blocking to prevent the spread of fire. It also helps with strengthening the walls and providing a surface to attach cabinets. This is where it starts to look like something, the tilt-up stage. Get the entire crew together because these walls are heavy and it's going to take everyone you got to get them up in place. It'll take less than 2 hours to get all the walls on this level up and plumb. Everything is well organized and staged on the ground so that pushing the walls in place becomes very systematic. Systematic, yes, but I didn't say problem-free. Today's codes require extensive framing hangers and ties. That sometimes makes joining a corner even more challenging. Here our header hanger is putting up a bit of a fight, so it's going to take some persuading to work it in place. These metal hangers make the intersection of joists and headers considerably stronger than just nails alone. But they also make assembly a little tougher and more time-consuming. Once the walls are up, it's time for either floor joists or trusses. We're putting up trusses today for a low-pitched roof. Trusses or joists, they both go down in the same manner. Careful measurements are taken for your on-center locations, and the top plate is marked off for truss placement. Trusses are then carried into place. Some minor adjustments, and they're nailed down. Blocking is essential in all framing jobs, especially trusses. The blocking ties the trusses together, forms a ridge beam, and strengthens the entire system. It also helps keep a consistent dimension between the trusses, which is very important. The vertical pieces in the front of the truss is for parapet wall framing. As soon as you put down either joists or trusses, it's time for decking. Code usually calls out for wood structural panels. For the roof decking, 1/2-inch OSB is being installed. The floor got 1 1/8 tongue and groove OSB. OSB is made from wood strands glued together. It has greater shear strength than plywood and is typically less expensive. Its biggest disadvantage is that if it gets exposed to significant moisture, the edges can swell by up to 15%. Lastly, all our exterior walls get 1/2-inch OSB panels installed. This gives the structure considerably more lateral strength, and we need that because this is LA. We covered all the major steps about framing a large structure: layout, wall assembly, truss installation, sheathing. I just want to go into a few important details next. The details mainly have to do with construction connectors, from strapping to plates, joist hangers, brackets. It's all designed to make the structure stronger. To withstand loads, regular nails or screws just could not handle. Most every structure uses joist hangers and header hangers. It's commonplace in residential and commercial construction. These are prefabricated steel shear wall systems. It makes any large opening, like the garage door, much more stable and allows for greater framing spans. Along with regular hold-down bolts, you've got these oversized ones. These are designed for use with a restrained shear wall rod assembly. This rod connects every story of the structure to the foundation. It runs from bottom plate all the way up 4 stories to the top plate and acts like a big clamp for the entire building. The majority of framing components, except for studs, is engineered wood. meaning that it's man-made from strands, particles, fibers, or veneers of wood bonded together with adhesives. Here you have a glue lam header over the garage door, which nowadays is the norm. I-joists attached to laminated veneer lumber beams is also quite commonplace. LVL beams, like most engineered lumber, is stronger than regular dimensional lumber. It's being used everywhere. It even comes pre-cut for stair stringers. Hopefully this makes your framing estimating just a little bit easier, and as always, thank you for watching.